Hello everybody, good evening to you all. Welcome back to Vignan Junior College's channel. I am Aksa, Senior Faculty in Chemistry. Please subscribe this channel. So, we started classification of elements and periodicity in properties chapter. In this chapter, yesterday we discussed long form of periodic table, right? How many groups are there, how many periods are there. We were discussing long form of periodic table, right? So, in this periodic table, what are periods? Horizontal rows. What are groups? Vertical columns in this periodic table. How many periods are there? 7 periods. How many groups are there? 18 groups. What is the main basis for classification of elements in this long form of periodic table? Atomic numbers. The difference between Mendeleev's table and long form of periodic table, Mendeleev considered atomic weights as basis for classification, whereas Moseley, he considered atomic numbers basis for classification, right. What is modern periodic law? The physical and chemical properties of elements are the periodic functions of atomic numbers. Atomic numbers depends upon electronic configuration, right. So, in this table Bohr gave modern periodic table. Elements are arranged in the increasing order of atomic number or electronic configuration, right. So, we discussed yesterday about this table, how many periods, how many groups, which is the shortest period in this periodic table. First period, how many elements are there? 2. Which is the longest period? Sixth period, how many elements are there? 32 elements. Out of these 32, 2 in S block, 6 elements are in P block, 10 elements are in D block, 14 elements lanthanides should be placed along with lanthanum. So, altogether 32 elements are present in the 6th period, right. Now, which is the longest group in the periodic table? This is 3rd group or 3rd B group, right. There are 4 elements in D block and 14 lanthanides, 14 actinides, 28 elements should be placed along with lanthanum and actinium. So, 28 plus 4. So, there should be 32 elements in this group. So, 3rd group or 3B group, longest group, 6th period, longest period in this periodic table, right. Now, which period has solid, liquid and gaseous elements? We discussed yesterday. Tell which period has solid, liquid, gases? Except first period, every period has metal, right. First period has only gases like hydrogen, helium, they are gases. The remaining are solids, right. So, every period has gaseous element, all noble gases are gases. So, which period has liquids? Bromine, bromine is liquid. See here, 4th period has liquids. Similarly, mercury, 6th period has liquid. So, 4th period, 6th period elements have solid, liquid and gaseous elements, right. So, the 14 elements lanthanides from cerium to lutetium, 14 elements actinides from thorium to lawrencium should be placed along with D block, but they are placed separately, right. So, now what are typical elements? See, the 3rd period elements are called typical elements. What are typical elements? The 3rd period elements are called typical elements. See here, see sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. 3rd period elements are called typical elements, right. So, they resemble in properties with the remaining elements of particular group. See here, 2nd period elements, their properties are slightly different. For example, when I take first group, see here lithium, 2nd period element, in some properties lithium differs from rest of the family. Lithium is hard, others are soft. We can cut sodium with a knife, but lithium is somewhat hard. Lithium forms only monoxides, others can form peroxides. For example, sodium, it can form monoxide, peroxide. Potassium, it can even form monoxide, peroxide and even superoxides. Some properties first member, in the sense like second period members, they differ from rest of the family. So, third period elements are typical elements, they are similar in properties with other elements of each group, right. Now, we take what are representative elements? All S and P block elements except 0 group elements, they are called representative elements. What are representative elements? The S and P block elements except 0 group elements, 18th group, they are called representative elements. Then are normal group elements. What are rare earth elements? Lanthanides, right. So, what are rare earth elements? From cerium to lutetium, 58 to 72. Lanthanides are called rare earth elements. See this point? Lanthanum belongs to D block, but lanthanides are F block elements. See this point? Lanthanum belongs to D block, but lanthanides are F block elements. They start with cerium, ends with lutetium. So, 14 lanthanides are called rare earth elements. They are rarely found in Earth's crust. Transuranic elements, elements after uranium, they are called transuranic elements. See, thorium, protactinium, uranium, 92. Elements with atomic number above 92, they are called transuranic elements. So, these are some points about long form of periodic table. All actinides are radioactive, and in lanthanides only promethium 61. Promethium is radioactive, all actinides are radioactive, that means they disintegrate, right. So, they emit alpha, beta, gamma radiations, right. Now, we will start today's worksheet. We have given some questions in yesterday's related topic. Which of the following pairs of atomic numbers represent elements belonging to the same group, right? Which set of these atomic numbers should be placed in the same group, right? So, in each period we have discussed in the previous classes the 8 elements, that means first period 2 elements. See here, second period 8 elements, third period 8, fourth period 18, it goes on. So, difference between 2 elements, here 2, go on adding 8, 8, 18, 18, go on adding, they all should be placed in the same group, right. So, from elements up to 12, go on adding 8, after 12, from 13 atomic number onwards, after 13 you know, after that period transition elements are introduced. So, keep on adding 18, 18, 32. We will check once, see here 11, add 8, 11 plus 8 means you should get 19, but he said 20, they are not in the same group. Keep on adding 8, 8, 18 like that. After 12 what we said? Add 18. So, 12 plus 8, right. So, it should be 20. 12 and 20 should be placed in the same group. Next 13, add 18. After 12 what we said? Add 18. So, 13 plus 18 means 31. So, these two should be present in the same group, right. So, if I add 14, add 18, it should be 32. So, correct option should be 13, 31. These two atomic numbers should belong to the same group, right. Now, I am taking one more question. the longest and shortest periods in the periodic table. Just now we discussed which is the longest period, 6th period, which is the shortest period, 1st period, right. See the question carefully, longest. So, longest and shortest, first longest, next shortest, 6 comma 1. See, it is 1 and 6 also is there, longest 6, shortest 1. So, now I am taking, so this should be the correct answer. Now, see here, elements of a vertical group have same atomic number, same electronic configuration. Will they have same atomic number? No, every element in the periodic table have different atomic numbers. So, same atomic number is wrong. Elements of a vertical group have same electronic configuration. No, every element has different electronic configuration. It may be similar, not same. Same number of core electrons. In every group, you know, as we move 1s, 2s, 3s, core electrons are changing, inner electrons are changing. Same number of valency electrons, right. So, in a group, elements have similar valency shell configuration. That means similar number of valency electrons. So, correct answer should be same number of valency electrons. Now, I am taking one more question. See here, the subshells fill one by one for 4th period elements. We discussed yesterday in 4th period. What is the order of filling? See here, in the 4th period, 4s, 3d, 4p. That is the order of filling of various orbitals. See here, 4s, 3d, 4p. So, it should be, third option should be the correct answer. Each period order of filling we have discussed, 4s, 3d, 4p. So, third option should be correct. Among the following, see here, among the following, the period that contains solid, liquid and gaseous elements. We discussed bromine, it belongs to 4th period, mercury, it belongs to 6th period, right. So, bromine belongs to 4th period. So, which period has solid, liquid, gaseous element? Every period except first period has solids. Every period has gaseous elements, 18th group. So, where is liquid? 4th period, bromine. So, third option should be the correct, C should be the correct option. Which period in the periodic table includes S, P, D and F block elements, right. So, now see here, which period in the periodic table includes S, P, D and F block elements, right. See, first period has you know, right. See here, first period has S block elements. By definition, helium should be placed in S block, right. Second period, S block and P block, no DF. Third period, S block elements, P block elements, no D and F block elements. Fourth period, S block, D block and P block, no F block elements. Fifth period, S block, D block, P block elements, no F block elements. So, like that you check. Sixth period has S block elements, D block elements, P block elements and F block elements. So, what should be the correct answer? Sixth period has S, P, D and F block elements. Correct answer should be sixth period. Now, see here, without looking at the periodic table, select elements of third A group of periodic table. Atomic numbers are given. Without seeing the table, you just have to work out, right? When I say third A group elements, it is 13th group, right? It is in P block. Third A group means 13th group. It should be in P block, right? When I see third A group elements, their valency configuration NS2NP1 for third A group elements. For 1 A group elements NS1, 2 A group elements NS2, third A group elements NS2NP1. That means 3 electrons in the valency shell, right? Now, in the inner shell, you keep on adding 2, 8, 8, 18 like that, right? So, inner shell should have 2 electrons. So, then I am writing like n minus 1, that means core electrons, 2 electrons. So, overall the first element of third A group 3 plus 2. First element in a third A group should have atomic number 5. Now, keep on adding, add 8, 5 and 8, 13, right? After 12 what we said? Add 18, right? So, 18 and 13, 31. Add one more 18, 49. 5, 13, 31, 49. So, without using that periodic table, we should be in a position to identify, if you know the atomic numbers, which can be placed in the same group, right? So, this should be third A group means NS2NP1, 3 electrons are in the outside shell. Keep on adding inner shells, 2, 8, go on adding. So, it should be in the same group, right. So, fourth option D should be the correct answer. Now, see this question. The element 117, if discovered, would be placed in which group and period? If it was discovered 117 element, where it should be placed? We discussed yesterday, I have suggested 2 different ways to answer this question, right. See, we must by heart noble gases: helium, neon, argon, krypton, xenon, radon, oganesson. So, this is 2, 10, 18, 36, 54, 86, 118, right. So, these, if you know atomic numbers, then what is our question? 117 element, 118 is noble gas. So, our element should be 117. 118 is noble gas, 18th group. So, 117 should be in 17th group. 17th group means, now which period you tell? 1, 2, 3, 4, 5, 6, 7. 7th period and 17th group. Observe here, 7th period and 17th group. If you know noble gases, with respect to it, where is our X element? 118 is noble gas, it is in 7th period. See, 117 should be in 7th period, but 17th group, right. So, one more way I am telling. See, one more way how to do. Observe here. See, when I say 117, Z is equal to 117. Now, 86 is radon, that we must know. 86 is radon, right. So, radon core. Radon means helium, neon, argon, krypton, xenon, radon. Means 6th period over, now 7s, right. 6th period over, 7s. After 7s, how the orbitals are filled in 7th period? 7s, 5f, right, 6d, 7p. The filling of orbitals we must know, 7s, 5f, 6d, 7p. Now, s orbital can have a maximum of 2 electrons. there are 7 f orbitals, maximum 14 electrons. There are 5 d orbitals, maximum how many electrons? 10. Now you count. So this is 86, 88, 98, 102, 112. Then how many remaining? 5 are remaining. So 7p5. When I say 7s2, 7p5, it belongs to how to know group number in p block? This is a p block element. How to know group number? ns electrons plus np electrons plus 10. So 2 plus 5 plus 10. This is 17th group. For any element you can identify if you know that valency configuration, right. So, otherwise directly by hot noble gases with respect to this, where is our X element? So, correct answer is 7th period 17th group. Now, see the question, atomic number of nitrogen is 7, the atomic number of third member in the same family is, right. Atomic number of nitrogen is 7. When I say nitrogen is 7, keep on adding 8, 8, 18 we discussed, right. After 7 add 8, now it becomes 15. After 13th element what we said, go on adding 18. So, 15 plus 18, 33. So, first member, second member, third member. Atomic number of nitrogen is 7, atomic number of the third member in the same family, it should be 33. Correct answer should be 33, right. Now, I am taking one more question, observe. Match the following in view of period and orbital being filled. Now, see the question. Match the following in view of period, this is the period and orbitals being filled, right. So, second period, which orbitals are filled? 2s, 2p, we must know this, he will not give this in exam, 2s, 2p. So, sp are filled, third one, a should be 3. Now, check once, fourth period, how is the order? 4s, 3d, 4p, s, d, p, fifth one. Sixth period, what is the order of filling? 6s, 4f, 5d, 6p, s, f, d, p, right. So, s, f, d, p, second one. Seventh period, how the order? S, F, D, S, F, D, p orbitals are yet to be officially announced, p block elements. So, S, F, D in 7th period. So, third option should be correct. You must know the order of filling of various energy levels, sub levels in each main energy level, then we can easily answer such questions. Next, see this particular question. In the periodic table, an element with atomic number 56 belongs to, right. Just now we discussed by hot noble gases, helium, neon, argon, krypton, xenon, radon, 2, 10, 18, 36, 54, 86. Now, see the question, an element with atomic number 56 belongs to, 54 is noble gas, 18th group, then 55, 56, right, 55, 56, 54 is in 18th group, 55 should be in first group, 56 should be in second group, right. So, in the periodic table an element with atomic number 56 belongs to, right. So, it should belong to second group and which period? 1, 2, 3, 4, 5. 54 is in 5th period, 56 means next period, right. So, it should be in 6th period. 54 we know this is xenon, then 55, 56, first group, second group. Which period it should be? Already 5 periods over, next period should be 6th period, second group and 6th period. Now, see here some statements he has given. Following are some statements about modern periodic table. It consists of SPDF blocks. Is this correct? Yes, there are 4 blocks SPDF, right. So, this statement is correct. The energy levels filling order in 6th period is 6s, 4f, 5d and 6p, correct. 6s, 4f, 5d and 6p. How we can write this? Based on Euler diagram of bar principle. If you know that Euler diagram, how the energy levels they are filled with different electrons we can calculate. So, the energy levels filling order in 6th period is 4f, 5d, 6p. So, this is also correct. Now, third A group contains maximum number of elements. Is this correct statement? Third A group element. Third A group means 13th group, P block. Will it contain maximum elements? No. Third group or 3B group. Third group. Third B group or third group elements. Originally the third group has 4 elements, 14 lanthanides, 14 actinides should be placed here. So, this should be the longest group with 32 elements, right. So, now see the point, third A group contains maximum number of elements, wrong. Third B group or third group. Latest IUPAC recommends like 1 to 18 from left to right, 1 to 18 groups, right. So, third A group contains maximum number of elements should be wrong statement. So, only 1 and 2 are correct. Correct answer should be A. Now, see the question, elements of atomic number 93 onwards. We discussed as soon as we started this session, we discussed few topics. What are transuranic elements? Elements after uranium. Uranium is 92. So, elements from 93 onwards are called transuranic elements. Actinides, lanthanides. So, this is transuranic element. So, this should be the correct answer. Transuranic element, elements after 92. Now, see this question, elements whose electronic configuration is 1s2, 2s2, 2p6, 3s2. See here 10 plus 2, when I say 3s2, that belongs to S block, 3s1 first group, 3s2 second group. So, first group, second group elements, they are all metals except hydrogen, right. See here, elements whose electronic configuration is 1s2, 2s2, 2p6, 3s2, that means 3s2, third period, S block means it is a metal. What is it? Magnesium, right. So, it should be a metal. See here, except hydrogen, all S block elements are metals, all D block elements are metals, all F block elements are metals. In the P block, we have mostly non-metals, last elements few are metals and some metalloids, right. So, metal should be the correct answer. Now, see here, which of the following sets belong to the same period? We must know at least 1 to 30 elements in a serial order. After you got 1 to 30 elements, names, atomic number, serial order, then you should learn how to, every group downwards you have to by heart, right. So, now see here, which of the following sets belong to the same period, right. So, lithium, sodium, potassium, they belong to same group, not period. Read the question, read carefully, period. These three belong to the same group. Now see here, lithium, magnesium, calcium. Lithium is here, magnesium. Lithium, sodium, potassium, same group. Lithium, magnesium, calcium, they are not in the same period, different. Then nickel, copper, zinc, they are transition elements, right. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So, these three belongs to the same period. These three comes under 3D series, transition elements, D block elements. Next, fluorine, chlorine, bromine, they belong to same group, right. They are halogens, fluorine, chlorine, bromine. Now, I am taking one more question. Which is a typical element? Just now we discussed, third period elements are called typical elements. We must know at least 1 to 20, 1 to 30 elements in a serial order we must know, right. So, bromine, fluorine, chlorine, bromine, third, not third, fourth period. When I say calcium, fourth period. Iron, 4s, 3d, it belongs to fourth period. Aluminium is third period elements, it is called typical element. So, correct answer should be aluminium. Third period element resembles in properties with other elements of every group, that is why they are called typical elements, similar. Now, see the question, the first member of rare earth element. What are rare earth elements? Lanthanides. Lanthanides are called rare earth elements, right. What are they? From cerium to lutetium. So, what is the first member? Cerium. Cerium to lutetium, 58 to 71, they are called lanthanides. It is not cesium. Cesium is first group elements, cerium to lutetium. First member of lanthanides, they are rare earth elements. Next, lanthanum belongs to D block, lanthanides are F block elements. Just we will come back within 1 minute. Okay, welcome back. We are doing some worksheet questions. Observe here. Which group of the periodic table has only gaseous elements? Which group? 18th group has only gaseous elements. Helium, neon, argon, krypton, xenon, radon. So, 18th group has only gaseous elements, or 8th group, 0 group, right. So, 18th group, D option should be correct. Now, see here, number of gaseous elements in the periodic table. How many gaseous elements are there in the periodic table? There are 11 gaseous elements. What are they? Hydrogen, nitrogen, oxygen, fluorine, chlorine, then noble gases, helium, neon, argon, krypton, xenon, radon. So, there are 11 gaseous elements in the periodic table, right. So, correct answer should be 11. Now, see the question. Filling of elements in 4th period starts with. Filling of elements in 4th period starts with. When I say 4th period, you know 4s, right, then 3d and 4p. In any period starts with s orbital filling, right. So, it should be 4s, B option should be correct. In every period the electrons are first filled in s orbitals. So, 4s should be the correct option. So, we have discussed in the long form of periodic table different periods, different groups, and we discussed elaborate about this long form of periodic table. This is one type of classification into periods and groups, one type of classification. One more type of classification now we are going to discuss. This is classification of elements into blocks, right. The elements are classified into 4 blocks, S block, P block, D block, F block elements, right. See, depending upon the shell to which the last electron enters. What is actually this last electron? See this point? When I say for example 1s1 hydrogen, 1s2 helium, 1s2 2s1 lithium. What is the difference between these two? 1 electron. Difference between these two? 1 electron. So, that last electron by which electronic configuration of one element differs from the preceding element, that last electron is called differentiating electron. What is differentiating electron? The electron by which electronic configuration of one element differs from the preceding element, that is called differentiating electron, right. So, based on entry of differentiating electron into various orbitals, the last electron enters into which orbital. So, based on that, elements are classified into 4 blocks, right. Right. Now, see here. So, there are 4 blocks in the periodic table, S block, P block, D block, F block. What are S block elements? Just now we discussed. Based on entry of last electron, differentiating electron into various orbitals, the elements are classified into 4 blocks. So, what are S block elements? If the differentiating electron enters into ns orbital of the valency shell, outermost shell, they are called S block elements. What is that last electron? Differentiating electron. Now, what are P block elements? If the differentiating electron enters into p orbitals of the outermost shell, they are called P block elements. What are D block elements? If the differentiating electron enters into d orbital of penultimate shell, ultimate, penultimate, last shell, ultimate, last but one, penultimate shell. What are D block elements? If the differentiating electron enters into d orbital of penultimate shell, last but one shell, they are called d block elements. What are f block elements? If the differentiating electron enters into ultimate, penultimate and T-penultimate, last but two shell, n minus 2, n minus 1, n. What are f block elements? If the differentiating electron enters into n minus 2 f orbital, or if the differentiating electron enters into f orbital of anti-penultimate shell, they are called f block elements. So, based upon the entry of differentiating electron into various orbitals, the elements are classified into 4 blocks, right. So, we are studying now classification of elements into blocks, right. So, there are now we are starting S block elements. What are S block elements? If the differentiating electron enters into ns orbital of the outermost shell, they are called S block elements, right. Now, how many groups are there in S block? There are 2 groups, just now we have seen. There are 2 groups in S block. What are they? First group, second group, 1A, 2A group. First group, second group, or 1A group and 2A group. See, this particular hydrogen we are studying separately. In first year syllabus we have hydrogen and hydrogen and its compounds, a separate chapter. For +1 students, hydrogen, a separate chapter. For board intermediate students, it is hydrogen and its compounds. So, we are studying hydrogen as a separate unit, but remaining when I take alkali metals, alkaline earth metals, when I take S block elements, we are just omitting hydrogen in our discussion. So, alkali metals from lithium to francium, like this we are discussing, from beryllium to radium. So, like that we are discussing, right. So, S block contains 2 groups. What are they? First group and second group, 1A group and 2A group. What is their valency configuration? When I say first group, NS1, when I say second group, NS2. So, overall if I write NS1 to 2, the valency configuration of first group elements NS1, second group elements NS2, right. So, we are studying about S block elements now. There are 2 groups in this block. First group elements are called alkali metals, we omitted hydrogen. Second group elements are called alkaline earth metals, right. So, their valency configuration NS1 to 2. Now, what are characteristics of S block elements? When I see their properties, characteristics, see all S block elements, hydrogen we omitted. So, alkali and metals and alkaline earth metals, they are all solids, they are all metals. When I say metals, right. So, they are good conductors of heat and electricity, right. So, they have 1 electron, 2 electrons in the valency shell. When I say alkali metals, their valency configuration NS1, down the group, lithium, sodium, potassium, rubidium, cesium, francium, size of atom increases. Why size increases? Because differentiating electron enters into a new shell, 2s1, 3s1, 4s1, size of atom increases. As size increases, what happens? So many inner shells are added. So, we can easily remove outer electrons. If inner shells are added, shielding effect increases. So, we can easily remove outer electrons. So, down the group reactivity increases, because when size goes on increasing, so many inner shells are being added. Number of inner shells goes on increasing, then what happens? So, we can easily remove outer electrons. Their ionization potential values, as size increases, ionization potential values decreases. The alkali metals have only 1 electron in the valency shell, their size is very big. So, they have low ionization potential values. That means, we can easily remove electrons, right. So, they are highly reactive, reactivity increases down the group, right. And first group elements NS1, they can lose one electron, they can show +1 oxidation state. What is oxidation state? The charge acquired by an element either in combined state or in free state, that is called oxidation state. What is oxidation state? The charge acquired by an element either in combined state or in free state, that is called oxidation state, right. So, first group elements have NS1, they can lose one electron, they show +1 state. Second group elements NS2, first group, second group, they can lose 2 electrons. See, every element tries to gain, share or lose electrons to attain stable octet configuration, right. So, instead of gaining 6 electrons, it can lose 2. Instead of gaining 7 electrons, it can lose 1. So, their common oxidation states +1, +2, right. So, they are highly reactive and they are never found in free state. Alkali metals, you cannot see in Earth's crust, we cannot find this sodium. It is always available as some salts form like rock salt NaCl, right, chili salt P3, like NaNO3, always available in combined state, right. So, these are all some properties, they have very low ionization potentials, they show +1, +2 oxidation states, right. So, they are electropositive. What does it mean? Tendency to lose electrons. What is electropositive nature? Tendency to lose electrons. A reducing agents. A reducing agent loses electrons. Why they are good reducing agents? They have big size, only 1 or 2 electrons in the valency shell. That is why they can lose electrons. They are electropositive, they are good reducing agents, right. Now, you know, how can we say this particular point? If I take some cesium, if you expose to a light, right, photoelectric effect, when a radiation strikes a clean metal surface, electrons are ejected, right. Only 1 or 2 electrons, especially cesium, potassium, they have 1 electron in the valency shell. When it is exposed to light, it emits, ejects electrons. So, they are reducing agent, they lose electrons, they are electropositive. So, they mostly form ionic compounds, big size, Fajan's rules. In chemical bond chapter, we will be discussing in detail which type of cation show ionic bonds, right. So, big cations form ionic compounds, right. So, especially lithium and beryllium, because of small size of cations, they mostly form covalent compounds, right. Especially beryllium, because of smaller size even than lithium, it mostly forms covalent compounds. So, these are all some properties. So, we discussed S block. What are S block elements? If the differentiating electron enters into NS orbital of outermost shell, they are called S block elements. How many groups are there? There are 2 groups, first group or 1A group, second group 2A group. What is their valency configuration? First group NS1, second group NS2. What are their properties? They are metals, they are good reducing agents, they are highly electropositive, they are good conductors of heat and electricity, they can show +1 and +2 oxidation states, right. So, these are all some properties of alkali metals, alkaline earth metals. See, helium should be placed in S block by definition. What are S block elements? If the differentiating electron enters into NS orbital of outermost shell. In helium, hydrogen 1s1, helium 1s2. So, by definition, helium should be belongs to S block, it should be placed along with S block. But it is placed under P block because it shows similarity with noble gases, right. So, it has high ionization potential values. It can gain one electron, it has one S2 means stable configuration, right. So, it resembles noble gases in properties. So, it is placed under P block. By definition, helium should be placed along with S block elements, right. Due to similarity in properties and completely filled valency configuration, it is placed under 18th group, right, exception. Now, we are starting P block elements. What are P block elements? If the differentiating electron enters into p orbital of valency shell or outermost shell, they are called P block elements. That means, the last electron enters into p orbital, right. So, how many groups are there in P block? See, there are 3 p orbitals, px, py, pz. Each orbital can have a maximum of 2 electrons. 3 p orbitals, together 6 electrons are possible, filled. So, there are 6 groups in P block, right. 2 groups in S block, S can have maximum 2 electrons, 6 groups in P block, right. P orbitals together can have 6 electrons maximum. So, there are 6 groups in P block, right. So, what are those 6 groups? They are, now I am taking, now see here. So, there are 6 groups in P block. What are those 6 groups? They are from 13th, 14th, 15th, 16th, 17th and 18th group, right. From 13th to 18th group, 6 groups are present in P block. You can write like 3A, old version, 4A, 5A, 6A, 7A and 0 group elements. So, how many groups are present in P block? 6 groups. What is their valency configuration? So, they have NS2, NP1. P orbital is being filled, NP1, NP2, NP3, it goes on till NS2, NP6. So, their valency configuration NS2, NP1 to NS2, NP6, right. So, what are P block elements? How many groups are there? What is their valency configuration and what are their properties, right. We are discussing mainly 4 points about each block. What are P block elements? If the differentiating electron enters into p orbital of outermost shell, they are called P block elements. How many groups are there? There are 6 groups from 13th to 18th or 3A to 7A and 0 group. What is their valency configuration? NS2, NP1 to NS2, NP6. Right. Now, see here. So, their valency configuration NS2, NP1 to 6, right. So, for 13th group NS2, NP1, 14th group NS2, NP2, each group we are mentioning. 15th group NS2, NP3, they are called nicogens. Nigmos means suffocation, nicogens. Next, 16th group NS2, NP4, they are chalcogens, ore forming. Next, 17th group NS2, NP5, they are halogens. Halos means season, gens means bond, right. So, salt producers. Next, 18th group NS2, NP6, they are noble gases, right. So, the 18th group elements, they are also called as inert gases. Why they are called inert gases? Because they have stable NS2, NP6, octet is complete. So, except helium, all noble gases have stable octet configuration in the valency shells. So, they cannot readily take part in reactions. If you want to remove one electron, very high ionization energy is required, right. So, they are not very readily reactive, right. So, they are called inert gases. Under certain conditions at high temperatures, they participate in few reactions, hence they are called noble gases. So, this is about p block valency shell configuration. Now, we are starting characteristics of p block elements, right. So, when I say p block elements, see they are mixed, that means some are non-metals, very few metals, some are metalloids, mixed properties, right. So, most of the non-metals except hydrogen, all non-metals are placed in p block, metalloids, semi-metals are placed in p block, few metals are placed in p block. So, it has like mixed properties, right. If I take 18th group, just now we discussed, they have stable NS2NP6 valency configuration. So, they cannot readily take part in reactions, hence they are called inert gases, right. The inert gases, they are rarely found in air, hence they are called rare gases. See this point? Inert gases are rarely found, traces of inert gases are found in air, they are called rare gases, right. What are rare earth elements? Lanthanides. What are rare gases? Inert gases. See, similarly, 16th, 17th group elements, they are mostly non-metals, and they have high negative electron gain enthalpy. What is this electron gain enthalpy? See, when an electron is added, when you add one electron to an atom, how much energy is released? Usually the 16th and 17th group elements, they have small size, left to right, differentiating electron enters into the same period, size shrink, size decreases. So, 16th, 17th group elements, their sizes are small. So, if you add one electron, they can readily accept electrons to attain stable octet. So, more energy is released, delta H is equal to negative. They have high electron gain enthalpy values, more negative electron gain enthalpy values, right. So, they have mostly, they are all non-metals, and they can gain, 16th group elements can gain 2 electrons to attain stable octet. 17th group elements, they can gain 1 electron to complete the octet. So, they readily accept electrons. They have negative electron gain enthalpy. What is electron gain enthalpy? The amount of energy released when an electron is added to an isolated neutral gaseous atom. How much energy is released when an electron is added to an isolated neutral gaseous atom? That is called electron gain enthalpy. Because of small size, 17th group elements, 16th group elements, they can readily accept electrons. Moreover, they have NS2NP5, NS2NP4. So, to attain stable octet configuration, they can gain electrons, right, 1 electron to attain stable octet, right. So, some p block elements, they are good oxidizing agents. An oxidizing agent accepts electrons. Under S block, what we said? They are reducing agents, they can lose electrons. Cesium, potassium especially, they can emit electrons, they show photoelectric effect. So, S block elements, reducing agents, P block elements, oxidizing agents. They can, some of these P block elements, they can accept electrons readily, they are oxidizing agent. Among all these elements, like fluorine is the best oxidizing agent, right. It can readily accept electrons because of small size and high electronegativity. So, we will continue in the next class. So, thanks for joining. Please subscribe this channel.